Hello my dear class 10 students, how are you all? How is your day going? Good morning to you all. I hope you're doing amazing. How is your preparation going my dear kids? Hello everyone. Yes, hello. A very warm good morning to you all. Good morning. Yes, good morning. So, are you ready to complete chemistry in 3 hours? In 3 hours, we'll be completing whole chemistry. You have 4 chapters in chemistry. We will be completing all these 4 chapters. Okay? So, are you ready, my dear kids? Yes, it looks like you all are. Okay. So, if you have any doubts or anything else, do write your doubts. I will try to answer your doubts as much as I can as your board exams are coming nearer and nearer. How are you feeling? Are you feeling nervous, my dear kids? Do not feel nervous. Your Ekta Ma'am is here and all the other teachers are working tirelessly for you to get better, for you to score good in your exams. Okay? So if you have any doubts, do drop them in this live section and I will try to answer your doubts. Okay? Moving on, let's start. Chapter 1, Chemical Reactions and Equations. Chemical Reactions and Equations. So in Chemical Reactions and Equations, we talk about chemical reactions. What are chemical reactions? Chemical reaction is a process in which one or more substances get transformed into a new substance. One or more substances get transformed into a new substance with new chemical properties. The compound or the substance that you are getting out of a reaction is a totally different species. Okay, let's say if you combined A and B, what product will you get, my dear kids? You will get C, maybe you get AB. Let's say you got AB. The reactant, the left side is called the reactant, the right hand side is called the product. In between we have an arrow. Okay, so in a chemical reaction, one or more substances combine to form a different compound, a new compound with different chemical properties. Okay, what is happening here in terms of bond also? Yes, my dear kids. Good morning, everyone. Good morning. Yes. So, what is happening here actually? The bond, initially there was no bond between A and B. But here there is a bond formation happening, right? There is a bond formation happening. Similarly, let's say if I have this compound, and if this is a chemical reaction happening, so what is happening here? The bond between C and D is getting broken. Okay, so what is happening? You can say there is a rearrangement of atoms happening, ma'am. There is bond formation happening, there is bond breaking happening, there is rearrangement of atoms. So these 3 things are happening whenever a chemical reaction is there, whenever a chemical reaction is happening. Okay, now what are the characteristics of a chemical reaction? What are the characteristics of a chemical reaction? How do you identify whether a chemical reaction is happening or not? You have 5 criteria. Evolution of gas. For example, if you react zinc with sulfuric acid, we get zinc sulfate. If you react zinc with sulfuric acid, you get zinc sulfate plus hydrogen gas is evolved. This is a chemical reaction. Okay. Hold on a second. Let me arrange the color. Yes, this is visible. Okay, so when zinc and sulfuric acid is combined, the zinc hydrogen gas is getting evolved. This is a chemical reaction. Okay, that is one characteristic. Characteristic means how do you identify what is happening. Okay, second is formation of precipitate. When sodium sulfate combines with barium chloride, when sodium sulfate combines with barium chloride, what are we getting? Sodium chloride and barium sulfate, a precipitate of barium sulfate. Okay, so in this reaction, as formation of precipitate is happening, in this process, as formation of precipitate is happening, we call it, yes my dear kids, we call it chemical reaction. Clear? Yes. If it is clear, say yes in the live section, live chat section, okay? Yes, it is clear. Okay. Next one is change in color. Whenever you observe any change in color, for example, when you have copper sulfate reacting with iron, what is the color change? What is the color change? Write down the color change, please. Okay, so when copper sulfate reacts with iron, copper sulfate is blue in color, right? And when it reacts with iron, we get iron sulfate and copper, right? Iron displaces copper from its compound. Iron sulfate is, what is the color of iron sulfate firstly? Okay, and what is the color of copper? Copper is reddish brown in color. Iron sulfate is white in color. Okay, so the color changes from blue to reddish brown. Okay, blue to green, blue to reddish brown. Okay, next second, hold on a second. Yes, okay. Hello. Yes, good morning. Okay, so a chemical reaction is characterized by the change in color. Correct. Color changes from blue to green. Color changes from blue to green. Okay, that is due to iron sulfate. Iron sulfate is green in color. Correct. Okay, next one, change in temperature. If in a reaction the temperature is getting increased or decreased, if in a reaction you are reacting to compounds, okay, and the temperature is getting increased, that is considered a chemical reaction. And if you are combining two atoms or substances and the final temperature is getting decreased, that is also called a chemical reaction. Okay, you have heard of exothermic, endothermic. Okay, we will discuss them, don't worry. Last is change in state. Whenever there is a change in state involved, it is considered as a chemical reaction. For example, have you burnt candle, right? So candle is, you have this thread coming out from the candle. If you burn it, where did all the candle go? Candle is solid in state, right? And it gets converted into carbon dioxide and wax, right? Which is liquid and gas. So solid is getting converted into liquid and gas. That is a chemical reaction happening, right? Combustion is happening. Okay, so that is a chemical reaction. Now, how do you represent this chemical reaction, my dear kids? How do you represent it? For example, we know your name is Arambhyan, your name is Ansh, but how do you write your name down? Okay, how do you write it on a paper? Okay, using English alphabets, using Hindi, whatever you are using. Okay, so how do you write it? The way of writing a chemical reaction, we know reactions are happening. Okay, we know candle burning is also a reaction, but you won't draw the candle on the paper and then say this is a chemical reaction. No, my dear kids, what you will do, you will write it that we have let's say wax in here, it is getting converted into carbon dioxide plus liquid wax. Okay, that is a way of writing. So chemical equation is a shorthand way of writing shorthand way of writing a chemical reaction. Clear? Now, how do you write a chemical reaction? By using chemical equation, right? Now, in chemical equation also, you can write a reaction in 3 ways. What are those 3 ways? Yes, word equation. You can write using words. You can write using words. Whatever you are using, magnesium is there, oxygen is there, we are getting magnesium oxide. Magnesium is there, oxygen is there, combining and we are getting magnesium oxide. Second way is using skeletal equation. What are these skeletal equation? You are just replacing the words with a chemical formula, with the chemical formula of the compound. That is a skeletal equation. Okay, so for example, if we replace magnesium by Mg, oxygen by O2, we get magnesium oxide, which is MgO. Okay, now these two are not sufficient enough. The correct way of representing a chemical equation, chemical reaction, is balanced equation. Okay, it is a balanced chemical equation. Okay, in balanced chemical equation, firstly, a balanced chemical equation follows law of conservation of mass. Law of conservation of mass states that mass can neither be created nor be destroyed. It can only be transformed from one form to another. It can only be transformed from one form to another. Okay. Next one is, in a balanced chemical equation, number of atoms on the reactant side and on the product side remains same. Both the reactants and the product side are balanced. Okay. Now, to get more information from a balanced chemical equation, for example, here, this equation, we have 1 magnesium on the reactant side, 1 magnesium on the product side, 2 oxygen on the reactant side and only 1 oxygen on the product side. So, what we will do? We will balance it. Yes, we will balance it, my dear kids. How do we balance it? We will add 2 oxygens on the product side. We add 2 oxygens on the product side. Now, number of oxygen is balanced, correct? But what about the number of magnesium? Number of magnesium is not balanced. So, what will you do? You will add 2 on the reactant side also, and that's how you get a balanced chemical equation. Now, to get more information from a chemical equation, what do? We add physical states of the reactants and the products. Okay, we add physical state of the reactant and the product, that we combined a solid and liquid and we got a gas. For example, magnesium is solid, oxygen is gas. What is the magnesium oxide? It is solid. Magnesium oxide is solid. Yes, hello. Yes. So yeah, skeletal equation is a way of writing a word equation where you are just replacing the words with the chemical formula. But skeletal equation is not balanced, my dear kids. Yes, skeletal equation is not balanced. Okay, moving on. Chemical reactions, different type of chemical reactions. What are the different type of chemical reactions? Okay, we have, these are the types, right? 1, 2 else are there, but these are the major types. Okay, let's start with combination reaction. What is a combination reaction? When two or more substances or elements combine to give a single product. Okay, when you have 2 or more reactants and they combine to give a single product, that is a combination reaction. Now tell me in the chat section that what is the nature of combination reaction? When 2 atoms are combining, will they release energy or will they absorb energy? Will they release energy or will they absorb energy? Okay, next one is decomposition reaction. What is decomposition reaction? When single product gets broken down into single reactant gets broken down into multiple products. That is called a decomposition reaction. Okay. Yes, when combination reaction is happening, it releases energy, and energy release is called exothermic. So your combination reactions are exothermic in nature. combination reactions are exothermic in nature. Okay. What about decomposition? You have one compound, you have one reactant, and it is getting broken down into multiple products. So think about it, whenever you are breaking something, my dear kids, whenever you are breaking something, you are giving energy to it. You are giving energy. Energy is being supplied. So decomposition is called endothermic. Decomposition is called endothermic. I hope it is clear. Okay, moving on to the next reaction, displacement reaction. What is a displacement reaction? Yes, when more reactive element displaces a less reactive element from its compound. When a more reactive element displaces a less reactive element from its compound, it is called decomposition. Sorry, it is called displacement reaction. Yes, it is called displacement reaction. Okay, what about double displacement? Double displacement means in which there is a reaction in which there is an exchange of between cations and anions of reactants. There is an exchange between the cations and anions of a reactant. Okay, see, barium chloride, sodium sulfate. There is an exchange. We get sodium chloride and barium sulfate. Sodium chloride and barium sulfate. Okay. Moving on. Next type is oxidation reaction. What is oxidation reaction? Addition of oxygen or removal of hydrogen is called oxidation reaction, right? Addition of oxygen or removal of hydrogen is called oxidation reaction. For example, in this reaction, oxygen is getting added. It is called oxidation reaction, right? What about reduction reaction? Reduction reaction means removal of oxygen or addition of hydrogen. Removal of oxygen or addition of hydrogen, that is reduction. And if you combine these, if you combine oxidation and reduction, what kind of reaction we get? Yes, we get redox reaction. Yes, we get redox reaction, my dear kids. Yes, correct. That is a redox reaction. Yes. Do not worry, we will do the balancing part also. Correct. Okay. So, what is redox? Reduction plus oxidation. It is nothing but reduction plus oxidation. Clear? That is a redox reaction. Okay. Moving on. Now, what is the effect of redox reaction in our everyday life? What is the effect of redox reaction in our everyday life? We see two phenomena in our everyday life that are related to redox reaction. What are those phenomena? Corrosion and rancidity. Corrosion and rancidity. What is corrosion? Yes, rusting is corrosion. Correct. Yes, rusting is corrosion. Okay, corrosion means the deterioration of metal by the action of air, moisture or acids. Corrosion is the deterioration of metals due to the action of acids, air and moisture. Okay, due to these three, what happens? There is deterioration of metal happening. You have pure metal, right? Iron and everything. Okay, what happens? Iron gets converted into its respective oxide, hydroxide or sulfide. What is happening to these metals? They are getting converted into compounds. You have pure metal, iron. Iron ka rusting formula, rust formula of iron is iron oxide, right? So it is getting converted into their respective oxides, hydroxide or sulfide. That is corrosion. How do you prevent corrosion? By painting, by greasing, by, okay, this is not visible, by painting, by greasing or by coating with epoxy or acrylic, and galvanization. What is galvanization? Applying a thin layer of zinc. Applying a thin layer of zinc on metal surfaces. If you apply a thin layer of zinc on metal surfaces, it will prevent it from corrosion. How? Because zinc is more reactive than iron. So what it will do, it will get corroded itself and your iron will be safe, right? Same principle of as you apply lotion on your body, okay? The purpose of lotion is similar to galvanization, because it will lock the moisture inside and won't let the moisture escape, and thus your skin will remain smooth. Okay, next one is rancidity. Yes, Thank you so much. Rancidity. What is rancidity? Rancidity refers to the oxidation of oily and fatty foods. It refers to the oxidation of oily and fatty foods. Yes. Oxidation of oily and fatty foods, right? What does it cause? It causes an unpleasant odor or smell. It causes an unpleasant odor or smell to the food. Okay, so you can't consume any rancid food. Okay, for example, if you have eaten sometimes chips that doesn't smell nice, or any oily food that you have consumed that is sour, that has this unpleasant smell coming out of it, so never consume these kind of food. These are rancid. Okay, we call it oxidative rancidity because due to the action of oxygen on the oil and fat present in the food is getting rancid. That's why it's called oxidative rancidity. How do you prevent it? By adding antioxidants that will not let the oxidation happen, by flushing with nitrogen. If there is no oxygen supply, you will get your pure food, your food will not get rancid. Using airtight containers, again, if you use airtight containers, there will not be oxidation happening, right? There is no oxygen supply. And keeping in refrigerator. When you keep your food in refrigerator, what is happening actually? The temperature is getting decreased, and in that temperature oxidation won't happen. Okay, the action of the oxygen or the bacteria won't work at that temperature. It needs higher temperature to get to act. Okay, so that's why we say ki always keep your food refrigerated if you're not eating it. It will keep it fresh for some time. Moving on. Acid, bases and salts. Acids, bases and salts. So what are acids and what are bases? What are acids and what are bases? Acids are sour in taste. They turn blue litmus red. They give hydrogen ions in aqueous solution. They conduct electricity due to these hydrogen ions. They have a pH less than 7. Right? These are the characteristic of an acid. Now, there are two types of acid, strong acids and weak acids. What are strong acids? Strong acids are those acids which dissociate completely in aqueous solution. For example, sulfuric acid, hydrochloric acid, right? Weak acids are those acids which do not dissociate completely, or they only dissociate partially. Okay, let me give an example. If you have 100 molecules of HCl, yes, acid are of two types, strong acids and weak acid. And yes, carbonic acid is a weak acid. If you have 100 molecules of HCl, of hydrochloric acid, if you put it in water, it immediately ionizes at 99%. It will be there as H positive and Cl negative. 99%. As soon as you put it there in water, it is completely dissociated as H positive and Cl negative. Okay, but what if you take 100 molecules of, let's say, acetic acid? If you take 100 molecules of acetic acid, only one will be dissociated. Only one will be dissociated as acetate ion. CH3CO negative is acetate ion and H positive. Rest will be there, only one will be there like this, and 99 will be there as acetic acid only. 99 will be there as acetic acid only. Okay, now what about bases? Bases taste bitter in taste, right? They taste bitter. They turn red litmus blue. They give hydroxide ions. What are hydroxide ions? OH negative ions when dissolved in aqueous solution. Okay, water soluble bases are, okay, one question I have, are all the bases water soluble? Are all bases water soluble? Yes, not all bases are water soluble. Bases may or may not be water soluble. Bases may or may not be water soluble. Water soluble bases are called alkalis. Okay, you have bases, right? They may be water soluble, may not be water soluble. The water soluble bases are called alkalis. Okay, the water soluble bases are called alkalis. For example, sodium hydroxide, potassium hydroxide, they are water soluble bases. They solubilize in water. Okay, they are soluble in water. That's why they are called alkalis. Weak bases. Okay, alkalis, what about pH? Bases have a pH greater than 7, from 7 to 14, right? Okay, now there are two type of bases, strong bases and weak bases. What are strong bases? Strong bases are those bases which dissociate completely in aqueous solution. So when you put them in water, they dissociate completely and give what ion? Bases give OH negative ion. Okay, so they will be giving OH negative ion. Okay, next one, weak bases. Weak bases are those bases which do not completely dissociate in aqueous solution. They do not ionize completely. They are partially ionized. Okay, partially ionized. Examples include ammonium hydroxide. Ammonium hydroxide is a weak base. It only ionizes partially. That means similar to acetic acid. Only one will be there as NH4 positive OH negative. Rest all will be OH as ammonium hydroxide only. Okay, moving on. Now, what are the properties of acids? What are the chemical properties or chemical reactions shown by acids? Those were the physical properties. Okay, and now we will be discussing the chemical properties. What kind of chemical reactions are shown by acids? The first one is reaction with metals. Reaction with metals. So when acid and metals react, what does happen? Acids are acids. Metals are basic in nature, right? Metals are basic in nature, and when acid and base react, what do we get? A salt. What do we get? A salt. Sorry, not a salt. Pardon my language. We get a salt, right? Plus hydrogen gas. Plus hydrogen gas. Which gas is evolved? Hydrogen gas. Hydrogen gas burns with a hydrogen gas. How do you identify if there is a hydrogen gas? It burns with a pop sound. It gives a pop sound. Okay, for example, HCl is an acid, reacts with zinc. HCl is an acid, it reacts with zinc, and what do we get? Zinc chloride plus hydrogen gas. Zinc chloride plus hydrogen gas. Now, acids also react with metal carbonate or metal hydrogen carbonate. Metal carbonate ka example is Na2CO3 and metal hydrogen carbonate is NaHCO3. How do they react with these? So when an acid reacts with metal carbonate and metal hydrogen carbonate, always remember the nature. When acid is reacting with a base, we will always get salt. Salt is there. Salt will be there. Apart from salt, the byproduct will differ. If it is a metal, we get hydrogen gas. If it is metal carbonate or metal hydrogen carbonate, the answer is there, carbonate. So that means carbon dioxide gas will be released. Carbon dioxide gas will be released. Clear? Okay. How do acids react with metal oxides? Again, what is the nature of metal oxides, my dear kids? Write down what is the nature of metal oxides. We have acids, and the nature of metal oxides. Yes, metal oxides are basic in nature. Metal oxides are basic in nature. Metal oxides are basic in nature. So when an acid and base react, yes, when an acid and base react, what do we get? Salt. When metal oxide and acid will react, what we will get? We will get a salt. We will get a salt and water. And water. You know, when metal oxide are bases, acid bases, when they react, salt plus water we get. Okay. Next reaction. Reaction of metals. See, we have bases also, right? These were the chemical reactions that were shown by acids. They react with metal oxides. They react with metals, metal carbonates, metal hydrogen carbonates. Okay. Now, what are the reactions shown by bases? Bases react with metals. They also react with metals. Now, see, my dear kids, bases and metals have one thing in common. They both have same nature. What I mean by same nature is that bases tend to lose electrons. They want to donate electrons. Okay. Metals also tend to donate electrons. So both have same tendency. Both want to donate electrons. Okay. Clear? Okay. So some metals are there that do react with bases. What are these metals? What are these metals? Yes, these metals are amphoteric in nature. Again, metals, when we have done it, metals react with bases, we get salt and hydrogen gas. Okay. Now, what kind of metals react? Amphoteric. What are amphoteric metals? Amphoteric nature of metals or amphoteric metals mean they react with both acids and bases. That means if they are reacting with base, they will be the acid. If they are reacting with an acid, they will be the base. Okay. For example, we have zinc, aluminum and lead. All these are amphoteric in nature. So what do we get? Salt and hydrogen gas. Similar to reaction with acids, right? Okay. Now, bases also react with non-metal oxides. What is the nature of non-metal oxides? Yes, non-metal oxides are acidic in nature. Non-metallic oxides are acidic in nature. And when acid and base react, what do we get? Water. Salt and water. So, if you treat a non-metallic oxide with a base, what do we get? We get salt plus water. Sodium hydroxide on reaction with carbon dioxide, which is a non-metallic oxide, we get sodium carbonate and water molecule. Okay. Now, reaction with acids. How do acids and bases react? That is the third part of our chapter, salts. When acids and bases react, we get salt. Now, salts are of three types. Actually. Neutral salt, acidic salt and basic salt. So, we will discuss them in a little while. Okay. The next section is this one only. Okay, moving on. The pH scale. Now, what is the pH scale, my dear kids? pH scale is a scale that is used to represent the acidity or basicity. Okay, how much acidic or how much basic a solution is or a compound or a substance is. Okay, it tells us the number plus the what does it tell us? It tells us whether a substance is acidic or basic. Okay, so quality and quantity both it is telling. Okay, how much acidic or how much basic, and if acidic or basic or neutral also. Okay, it starts from 0, goes till 14. In between you have neutral. At 7 you have neutral. Okay, neutral substances lie around 7. Now you can see milk is slightly acidic. Milk is slightly acidic. Blood is slightly basic. Okay, blood is slightly basic. Okay, what else is there? The stomach acid is very acidic. Stomach acid is highly acidic. Okay, the acid that we have in our stomach is what? Which acid we have in our stomach? Yes, we have HCl, hydrochloric acid in our stomach. Okay, moving on. Yes, coffee is also acidic. Tomato have oxalic acid. Okay. Indicators. Next one is indicators. Now, what are indicators? So, indicators are substances that are compounds that are used to indicate whether the compound or substance we have is acidic or basic. Okay, they are used, they are way of indicating what kind of substance we have, whether it is an acid or a base. Okay, they do not tell the quantity, how much acidic or how much basic. They will just tell us, oh, it is acidic or it is basic. Clear? Okay, so what indicators we have in our syllabus? We have litmus paper. What is litmus paper? It is made up of this lichen plant, and that is a litmus paper. Okay, with acid, if in acidic solution, litmus paper, blue litmus paper gets turned red. Okay, in basic solution, a red litmus paper turns blue. Okay, next is phenolphthalein. Okay, phenolphthalein in acidic solution is colorless, but when put in basic medium it turns pink. Methyl orange. Okay, it is also a synthetic indicator. Okay, these two are synthetic indicator. Synthetic means they are synthesized in a laboratory. Natural indicator, can you tell me some natural indicator? Yes, red cabbage is one. Yes. Okay, apart from red cabbage, turmeric is also a natural indicator. Okay, methyl orange in acidic solution gives red color, and in basic solution it gives yellow color, Okay, now we have other set of indicators. Okay, we have natural indicators, we have synthetic indicators, then we have olfactory indicators. What are olfactory indicators? That relies on sense of smell, whose smell changes if they come in contact with acids or bases. For example, vanilla extract or onion. Clove is also there, CLOV, clove is also there. That is used as an olfactory indicator. Okay, so what happens when you put onion or vanilla extract in acid? They retain their odor. Okay, but when you put them in basic solution, when you put them in with bases, okay, what happens? They lose their odor. They lose their smell. Okay, olfactory means smell. Okay, in biology you have studied it, right? Yes, clove is also used as an olfactory indicator. There are three type of indicator. Natural indicator like turmeric or red cabbage. Synthetic indicators, what are synthetic indicators? Which are synthesized in a laboratory. Okay, phenolphthalein, methyl orange. Okay, next is olfactory indicators. Olfactory indicators are those which relies on sense of smell to tell us whether we are dealing with an acid or a base. Okay, so in acidic they will retain their odor, and in basic medium they will lose their odor. Okay, moving on. Salts, the last part of this chapter. Salt. What are salts? They are formed as a result of, what are salts? They are formed as a result of neutralization between acid and base. They are formed as a result of neutralization between acid and base. Now, in the previous slides we have discussed there are three types of salts: neutral salt, acidic salt, and basic salt. What are neutral salt? When a strong acid combines with a strong base, what do we get? We get a neutral salt. Okay, next one, acidic salt. When do we get an acidic salt? When a strong acid, this SA means strong acid, SB means strong base. Okay, when a strong acid combines with a weak base, we get an acidic salt. Okay, let's do one example also. If we have a strong acid like HCl and we have a weak base like ammonia is a weak base. Okay, we get a acidic salt which is NH4Cl, ammonium chloride. Ammonium chloride is an acidic salt. Correct. Next one, basic salt. basic salt. Basic salt, when do we get a basic salt? When a weak acid combines with a strong base. When the base is strong and the acid is weak, what kind of salt we get? A basic salt. Give me some example of it. Give me some example of it. Sodium carbonate, right? Sodium carbonate is one. Okay. So if we have carbonic acid, and it combines with sodium hydroxide. Now carbonic acid is a weak acid, okay? That is the acid that is present in acid rain. Okay, tell me the pH of acid rain. What is the pH of acid rain, and also at what pH our tooth start degrading? I'll tell you. Okay, so when carbonic acid combines with sodium hydroxide, what do we get? Sodium carbonate plus water. Now this is a basic salt. This is a basic salt. Okay. Now what are the properties of salt? They may be acidic, neutral, or basic, right? They conduct electricity, right? To conduct electricity, two conditions need to be fulfilled. Either they should be in molten state, or what? Either they should be in molten state, or yes, they should be in aqueous solution. There should be an aqueous solution of that particular salt, because only in those cases they have free ions. To conduct electricity, you need ions and electrons, either ions or electrons. Okay. So when you dissolve a salt in water, you have ions. Okay. When you melt it, you have ions. Okay. And these ions will conduct electricity. In solid state, they do not have these ions. That's why in solid state, they do not conduct electricity. All the ionic compounds also. They have high melting and boiling point. Why? Because they are ionic compound. They are composed of cation and anion. They are formed by transfer of electrons. Okay. Don't worry, we'll discuss it in the carbon and its compounds. Okay. That's why they have very high melting and boiling point, because you need very high energy to separate that bond, to break that bond. Okay. To break the ionic bond. That's why they have very high melting and boiling point. What are they soluble in? Since they are polar compounds, they are soluble in polar solvents. Polar solvents mean when you have, okay, polar solvents mean poles. There are poles in a particular solvent. Okay. Sometimes due to the electronegativity difference between two atoms in a compound, their charge separation happens. One gets positively charged and the other gets negatively charged. For example, in H2O, right? In H2O, the charge separation is like this. Water, H positive is there and OH negative is there. Okay. Due to the electronegativity difference between hydrogen and oxygen. Okay. These are called poles. Pole, positive pole, negative pole. Okay. These are called polar solvents. The solvents that have these poles in them, they are called polar solvents. Now, like dissolve like. For solubility, only one principle is there. Like dissolves like. So, if you have a polar solvent, they will only dissolve the polar compounds. Okay. Salts are polar compounds. They have ions, positive ion, negative ion. There are poles in them. So they will only solubilize in or soluble in polar solvents. Okay. Not in non-polar solvents. Non-polar, or you can say organic solvents. These do not have any charge. They are made up of covalent bonds. For example, petrol, benzene, etc. Okay. Moving on. Now, there are some salts that are very important. So, yes, to answer your question, yes, the pH should be, pH of acidic rain is less than 5.6. This is the pH of acidic rain. And in our mouth also, if the pH is below 5.5, 5.4 is less, then you can go in the range 5.5 or 5.4. This is the range. Okay. If the pH in our mouth is below that, so tooth decay will start to happen. Yes. Yes. So it is in the range of 5.5 to 5.4. Yes, I see all my kids answered correctly. Okay, next one is the salts. The major salts that we will be dealing in this chapter are, first is common salt. Common salt is a salt that we consume every day in our meal also. Okay, it is sodium chloride. Now, one method I told you that yes, you synthesize sodium chloride by, if you take sodium hydroxide and you combine it with a very strong acid, which is hydrochloric acid, and that's how you get sodium chloride. But do you think we will be able to consume it because it has this strong acid? Can we consume this much strong of an acid or this much strong of a base? No, right? It won't be edible. We can get sodium chloride, but it won't be edible for us humans. So where do we get it from? We actually, you see in sea water, you have plenty of salts. Enough amount of salt is there. It's very salty, right? If you have ever been to sea. Okay, so what do? We collect seawater. And then we vaporize that water, and what are we left with? We are left with salt. And that's how you synthesize common salt. Okay, we use it as a food preservative. In food we put it, right? And also remember this point, it is used as a raw material, major raw material for the synthesis of what? Sodium carbonate and sodium hydrogen carbonate. What is sodium hydrogen carbonate? What is the common name of sodium hydrogen carbonate, my dear kids? Tell me the common name of sodium hydrogen carbonate. Okay, so it is a raw material for the synthesis of sodium carbonate and sodium hydrogen carbonate. Okay, I hope it is clear to you all. Next is sodium hydroxide. Now this is not a salt. Next one is sodium hydroxide or caustic soda. Okay, so how do you synthesize sodium hydroxide? By process called chlor-alkali process. It is a very important process, my dear kids, so pay attention. Chlor-alkali process is what? So when electricity is passed through an concentrated aqueous solution of sodium chloride. Okay, the word is concentrated. We have a concentrated solution of sodium chloride, common salt, right? Okay, so we take a concentrated solution of sodium chloride and we pass electricity through it. So what happens? Electrolysis happen. What is electrolysis? Decomposition you have studied, right? 3 ways we can do decomposition. We can do thermal decomposition, we can do electrolysis, or we can do photolysis. Thermal decomposition means you are providing heat energy for the decomposition to happen. I told you, decomposition reactions are endothermic in nature. So you provide energy in 3 ways. Either by heat, thermal, or either by electricity, electrolysis, or by sunlight, by providing sunlight. Sun is a source of energy, right? Jadoo ke jaisa. So sunlight, that is photolysis. So here we are doing electrolysis of what? Brine. What is brine? And concentrated solution of NaCl, that is brine. A concentrated solution of NaCl, that is brine. Okay, now what happens during the electrolysis? Chlorine gas is evolved at anode, hydrogen gas is evolved at cathode, and sodium hydroxide or caustic soda. Where do we get caustic soda? Caustic soda is also synthesized or is also present near cathode only. It is also produced or present near cathode. Okay, my dear kids, that's how you synthesize caustic soda. Yes. Now what is the purpose of sodium hydroxide? It is a good base, right? So we use it for detergents, paper, fabrics, okay, and also for degreasing metals. Okay, the uses, more than the uses, this reaction is important. Chlor-alkali process. Why do we call it chlor-alkali? Because chlorine gas and an alkali. What are alkali? We just discussed it. Alkali are water soluble bases. Okay. Alkali are water soluble bases. Okay, next compound or salt, next is this salt, calcium oxychloride. Calcium oxychloride or bleaching powder. So yes, okay, yes, the general common name of sodium hydrogen carbonate is baking soda. Correct. The common name of sodium hydrogen carbonate is baking soda. Clear? Okay, one more is there. Okay, when we will discuss the baking soda, I'll tell you the baking powder also. Okay, bleaching powder is calcium oxychloride. Calcium oxychloride. Okay, what is the formula? CaOCl2, right? OCl2, 2 oxygen and 2 chlorine. Okay, how do you synthesize it? So in the chloralkali process, we get caustic soda plus chlorine gas plus hydrogen gas. So if we take chlorine gas from there and add it to dry slaked lime, we take the slaked lime, we dry it, we evaporate all the water, okay, and we take dry slaked lime and pass chlorine gas through it, what do we get? Bleaching powder. We get bleaching powder. This is bleaching powder. Now how do you activate the bleaching powder? It is bleaching powder, but it is not the compound that is acting as the bleaching agent. It is not the compound that is acting as the bleaching agent. What is the bleaching agent in this case? Yes, my dear kids, the bleaching agent is chlorine. Chlorine is the bleaching agent. What does the calcium oxychloride or this bleaching powder does? It acts as a storage thingy. Okay, it acts as a storage thing for this chlorine gas. Okay, for this bleaching agent, because it is very difficult. It is difficult to store chlorine gas. It's very difficult to store chlorine gas. Okay, that's why we store it in this form, calcium oxychloride, which is bleaching powder. As bleaching powder we store it. The bleaching agent in this case is chlorine gas. Okay, how do you activate it? By treating it with any dilute acid. If you treat bleaching powder with any acid, chlorine gas will evolve, and this will act as the bleaching agent. Okay, your purpose will be served. Now where do you use bleaching powder? Use bleaching powder to disinfect water, right? Also as an oxidizing agent, to bleach hair, to bleach clothes. That's where you use bleaching powder. Okay, moving on. Next one is baking soda. Baking soda. You have seen it. We have used it in our homes also, right? What is the chemical name of baking soda? Sodium hydrogen carbonate. Sodium hydrogen carbonate. How do you synthesize sodium hydrogen carbonate? Again, you take a brine. What is brine? And a concentrated solution of sodium chloride. And we put ammonia in it. And pass carbon dioxide gas through it. Okay, we put ammonia in it and pass carbon dioxide gas through it, and that's how you get sodium hydrogen carbonate. This process is called Solvay process. Actually, this is part Solvay process. The next step is you take this sodium hydrogen carbonate and we heat it. We call it soda ash. We heat it. What do we get? Sodium carbonate plus water. Okay, now if we add 10 water of crystallization to this sodium carbonate, we get washing soda. My dear kids. Okay, now this completed the Solvay process. This is the Solvay process. You take a brine, which is a concentrated solution of sodium chloride, add ammonia to it and pass carbon dioxide through it, and that's how you get sodium hydrogen carbonate, which is baking soda. Now heating baking soda, we get sodium carbonate. Sodium carbonate, if we add 10 water of crystallization to sodium carbonate, we get washing soda. This is washing soda. And this whole process is called Solvay process. This whole process is called Solvay process. Okay. Now this is baking soda. What about baking powder? We also use baking powder for baking purposes, right? So what is baking powder? Tell me what is baking powder? Yes. Baking powder is a mixture of baking soda and an edible acid, and any edible acid. What can that be? An edible acid, any. You have oxalic acid, you use tartaric acid, we eat tamarind mein hota hai, it is in tamarind. Okay, so normally we use tartaric acid. Clear? So baking powder is a mixture of baking soda and an edible acid, that is tartaric acid. Normally that's what we use. That is baking powder. The difference is if you want to rise, if you want, you know, your whatever you're cooking, mainly pakoda vagera, if you're cooking and you want them to look fluffier, that's when you use baking soda, because baking soda is basic in nature. Okay, remember this is basic in nature. Okay, but if you want a little different taste with the acidity also, what does this do? When baking soda is basic, we have an acid base, we get a salt. This salt has this pleasant taste, very pleasant sweet taste. So normally we use baking powder when we are baking a cake, muffin, cupcake, anything that we are baking. Okay, we use that to get the sweet taste, because this is basic, right? It will still be little bitter. Okay, that's where we use baking powder. I hope you know the differences now. Second last actually, washing soda. Washing soda is, we just synthesize washing soda. It is sodium carbonate decahydrate. Sodium carbonate decahydrate. That means it has 10 water of crystallization. It have 10 water of crystallization. How is it formed? It is formed when you have sodium carbonate. We synthesize sodium hydrogen carbonate, right, by Solvay process. This is synthesized by Solvay process. So if we synthesize sodium hydrogen carbonate or baking soda, and then we heated it. We heated baking soda, and that's how we get sodium carbonate. And if we add 10 water of crystallization, 10 water molecules to sodium carbonate, we get washing soda. What is washing soda? Sodium carbonate decahydrate. Sodium carbonate decahydrate. This is washing soda. Where is it used? It is used to remove permanent hardness of water and as a cleansing agent. It is basic, right? So you use it as a cleansing agent to clean floors, clean washrooms and anything. Okay, that is washing soda. Moving on. Last one, I believe, this is plaster of Paris. This is plaster of Paris. What is POP, plaster of Paris? Where is it used? Yes, we use it to, firstly, the major use that we all remember is for supporting fractured bones. If you have fractured bones, you use plaster of Paris. What is plaster of Paris? Calcium sulfate hemihydrate. How do you synthesize it? By gypsum. What is gypsum? Calcium sulfate dihydrate. Okay, when calcium sulfate is a salt, right? Calcium hydroxide and sulfuric acid. So that's how you get calcium hydroxide. That's how you get calcium sulfate. And if you add 2 water molecules to it, 2 water of crystallization to it, that's how you get gypsum. Okay, now we call it plaster of Paris because it was developed in Paris, because gypsum was plenty, the main source of gypsum was from Paris only. Okay, so if you take gypsum and heat it up to 100 degrees Celsius, if we heat it up to 100 degrees Celsius, it loses 1.5 water of crystallization. It loses 1.5 water of crystallization, and what do we get? We get plaster of Paris. We get plaster of Paris, my dear kids. Okay. What happens if we heat it above 100 degrees Celsius? Let's say if we heated it above 100 degrees Celsius, what will happen? Gypsum, we take gypsum and let's see if we heat it above 100 degrees Celsius. It will lose all the, yes, it will lose all the water molecules. Yes, it will lose all the water molecules. Correct, my dear kids. And we get calcium sulfate. This is dead bond plaster. It is used nowhere. It is used nowhere. Okay. So that is what happens if you heat gypsum greater than at a temperature greater than 100 degrees Celsius. It is used to support fractured bonds and make smooth surfaces smooth before plastering. You have seen the ceiling art in most of your houses. That is POP, that is plaster of Paris. Okay, they used plaster of Paris there, and that's how they made that designs in your ceiling. Okay, moving on. I believe, yes. Okay, that was it. Okay, that was half our portion done. 2 chapters are done. 2 chapters revision is done. If you have any doubts, do drop them and I will take a break. Let's take a break of 10 minutes, my dear kids. Okay, let me write it somewhere. I hope it is visible. A 10-minute break, just a little 10-minute break. Okay, I'll be back in 10 minutes. back, my dear kids, after the break. Let's start with the chapter metals and non-metals. This is one of the most scoring chapter, okay? Major question come from this chapter, so do not skip these and listen carefully, okay? Let's do the revision. Now, what are the physical properties of metals? What are the physical properties? So, metals are lustrous, they are shiny, right? They are really hard. They are really hard. Okay, they are good conductors of heat and electricity. They are good conductors of heat and electricity. They are ductile. What does ductility means? That means they can be drawn into thin wires. That means they can be drawn into thin wires. Okay. Have you seen copper wires, right? The electricity conducting wires we use for electricity purposes, that is copper wire. Okay. Next is malleable. What does malleability means? That if you beat metal with a thin sheet, you can beat metal with a thin sheet and it will get converted. Sorry, if you beat metal, it gets converted into thin sheets. Okay. For example, gold foil, silver foil, they are metals and you can make a really thin sheet. Gold foil is very thin. Silver foil is very thin, okay? You eat also, right? That is malleable. Sonorous means metal produces sound. I don't have any metal. This is a metal, but it doesn't produce sound. But you see, metals do produce sound. Okay. They are sonorous. Next, there are some exceptions to it though. Okay. There are some exceptions to it. There are some exceptions to it though. Okay, what are those exceptions? Let's talk about them. Okay, sodium and potassium. Sodium and potassium. Metals are supposed to be really hard, right? But sodium and potassium are your metals that are really soft. Sodium and potassium are metals, yet they are really soft. Okay. Next one is mercury. Mercury is a metal, but it is liquid at room temperature. It is not hard, my dear kids. Okay. Next one is gallium and cesium. Gallium and cesium have really low melting and boiling point. Okay. So even if you put them on the palm of your hand, they will melt. They will melt. Okay. So these are the exceptions. Moving on, my dear kids. Physical properties of non-metals. Okay, so non-metals show what properties? They are very soft, they are brittle, they are dull, they are bad conductor of heat and electricity. Again, there are some exceptions to it. Remember, the exceptions are more important than the rules. Okay, so focus on them. Moving on to the exceptions. Iodine. Okay. Metals are dull, right? Sorry, non-metals are dull, yes, but iodine, which is a non-metal, it is lustrous. It is lustrous, okay? Again, non-metals are really soft, but diamond, which is made up of non-metal, carbon, it is extremely hard. It is one of the hardest substance known to humankind, okay? Yes. Correct. So focus on the exceptions more. Next is graphite. Non-metals are supposed to be bad conductor of electricity, right? But graphite, which is made up of non-metal carbon, is a good conductor of electricity, my dear kids. Okay. Moving on. The chemical properties of metals. What are the chemical properties of metals? The chemical reaction shown by metals. So metals react with oxygen and they form metallic oxide. Now what is this? Tell me, what is the nature of these metallic oxides? Yes, these metallic oxides are basic in nature. Some metallic oxides are there that are amphoteric in nature. What is amphoteric? That is, they behave both as acid and base. That is, they behave as both acid and base. Okay, now these are the reactions shown by the metals with oxygen, right? And this is the color of product that we are getting. Sometimes this flame color can be asked, so focus on that. When potassium oxide gets burned, it gives lilac color, sodium oxide gives orange color, and rest do not give any color. Okay, next is, these are the first reactions, right? Reaction with oxygen. Metals also react with water, right? Metals also react with water, and they react with water differently. They react with water differently. And what define that? What determine that? If what determine which metal is reacting with what kind of water? That is the reactivity series, my dear kids. That's there only. Okay. We have a reactivity series of metals in which metals are arranged in decreasing order of their reactivity. Okay, so firstly we'll start with metal who will react with cold water. That means they are extremely reactive if they are able to react with cold water. Okay, and form metal hydroxide. Metal hydroxide and evolve which gas? Hydrogen gas. Plus lot of heat is also released. Now as you know, hydrogen gas is already used in, it's a very explosive gas. We normally use it for explosions, okay, for making firecrackers also we use it, okay, not for making, but yeah, for bombs and everything we use hydrogen gas. So when hydrogen and heat combines, there is fire, okay. So the hydrogen gas that is evolved for the case of these metals, sodium and potassium, it instantly catches fire. Okay, now metals, there are some metals who do react with cold water, but the evolution of hydrogen gas does not catch fire. The evolved hydrogen gas will not catch fire. What are those metals? Calcium, magnesium also there. No, calcium only. Yes, calcium only. Okay, so when calcium is treated with cold water, it forms metal hydroxide. Hydrogen gas is evolved, but this hydrogen gas does not catch fire. Why? Because it is not that reactive, okay. And one more thing happens, this calcium starts floating on the water. You have water, right, cold water, and if you add calcium to it, you get calcium hydroxide. Plus this calcium hydroxide or this calcium metal that we have put, it will start bubbling, it will start floating on the water surface. How does it happen? It happens because of these tiny hydrogen bubbles. These tiny hydrogen bubbles surround this calcium and they make it float on water. Okay, plus the evolved hydrogen gas does not catch fire because the reaction is not that explosive. Okay, next is metal reacts with hot water. How do metals react with hot water? When metals react with hot water, again we get metal hydroxide plus hydrogen gas is evolved. Again this hydrogen gas will not catch fire. Why? Because magnesium is much less reactive. As we are moving down the reactivity series, the metals are getting less reactive. Okay, so magnesium combined with water, hot water, okay, and we get magnesium hydroxide plus hydrogen gas is evolved. Again these hydrogen bubbles will help. What will they do? They will make this magnesium float on water. Now as we move down the reactivity series, my dear kids, what is happening? We have a reactivity series. Please write down, yes, what is the correct reactivity series order. I'll explain it in the next slide. So when we move down the reactivity series, what is happening? Reactivity is decreasing. The reactivity is decreasing for the metals. So that means they won't react with water normally as they should do. Then how will they react? You need to either increase the temperature or you need to provide any other catalyst. Okay, in case of water you increase the temperature, so from cold water to hot water and from hot water to steam, water vapors. So some metals are there that will react only with water vapors. And what are those metals? Aluminum, zinc and iron. These are less reactive metals. That's why they only react with water vapors. Okay, again they will form metal oxide, not metal hydroxide. Okay, they will form metal oxide. Why? Because at higher temperatures oxide is much more stable than hydroxide. Okay, because Steam means the temperature is above 100 degrees Celsius, right? Temperature is above 100 degrees Celsius. And at this much temperature, what is happening, my dear kids? The metal hydroxide is not stable. Here, metal oxide is stable. Metal hydroxide, definitely metal hydroxide will form. Then that metal hydroxide will decompose as metal oxide and water molecule will be released, okay? Now, there are some metals so poor, non-reactive at all. Lead, copper, silver and gold. Lead, copper, silver and gold. They do not react with hot or cold water at all, or neither steam. They do not react with hot water, cold water or steam, water vapors. Anything you put them, they are not reactive at all, my dear kids. Okay. Now, how does metals react with acids? How do metals react with acids? We have learned the reaction of metal reacting with oxygen, form metal oxide. Metal oxides are basic in nature. Why are they basic? Because, ma'am, if you combine metal oxide in water, we get a base. That's why they are basic in nature. Okay. Now, how do metals react with, what was the reaction? Last reaction we talked about. Do metals react with water? Okay. So, metal react with cold water, hot water, water vapors depending on the reactivity of the metal. Okay. Now, how do metal react with acid? You know acid, right? Nature of metal. Then base react, we get a salt, right? So metals react with hydrochloric acid and sulfuric acid very easily. They reacted. And this is the reactivity order, decreasing order of reactivity. Okay, but when it comes to nitric acid, the case changes slightly. The case changes slightly. What is the difference? What is that change? That is simple. As your nitric acid is a very strong oxidizing agent, very strong oxidizing agent. So what is happening here, as since nitric acid is a strong oxidizing agent, there is no hydrogen gas evolved. So whenever metal are reacting with an acid, what is happening? You get salt plus hydrogen gas. Salt plus hydrogen gas. Yes, correct, my dear kids. Only two exceptions are there. Magnesium and manganese. Yes, only magnesium and manganese will evolve hydrogen gas when reacting with nitric acid. Rest all the metals, they do not evolve hydrogen gas. They do not evolve hydrogen gas when treated with nitric acid. Why? Because nitric acid is a strong oxidizing agent. That means it adds oxygen. So what it will do, if you have hydrogen, it will add oxygen and we get a water molecule. We get a water molecule. Clear? Aqua regia. Aqua regia is a 1:3 mixture of concentrated nitric acid and hydrochloric acid. Concentrated nitric acid and hydrochloric acid. Okay. Now, highly corrosive in nature. Now, this mixture that we are making, aqua regia, firstly, the purpose of it is to dissolve gold and platinum. Why? Because they are not reactive at all. They are not reactive at all. They are noble metals. Noble metals. Okay. So, as you want them to dissolve, you want them to react, we make this mixture called aqua regia. Aqua regia is 1:3 mixture of concentrated HNO3 and concentrated HCl, concentrated nitric acid and concentrated hydrochloric acid. And it is very corrosive and fuming liquid. Corrosive and fuming liquid, and it is able to dissolve gold, silver and platinum. Okay, one question might come from this one. Moving on. Reactivity series, my dear kids. Yes, reactivity series. Okay, so where do we start from? Not the Katrina one. We are starting with our own please one. Okay, you can make one also. In last class, one student made it, so it was similar to this, but something different. So write that down in the chat section right now. Okay. So we start with please stop calling me a careless zebra. Instead try learning how copper saves gold, platinum. Okay. If you have anything else that mnemonic work for you, use that mnemonic. For me, I use this one. It is the one that I remember, but if you have any other Hindi, English, it doesn't matter, use that one. Okay, because your exam are really soon. Okay, so please means potassium, stop means sodium, calling means calcium, me means magnesium, A means aluminum, careless means carbon, zebra means zinc, instead means iron, try means tin, learning means lead, how means hydrogen, copper means copper, saves silver, gold, platinum. Okay, so this is the decreasing order of reactivity series. Decreasing order. Okay, let me write it. decreasing order of reactivity series. So as we are going down, these are most reactive. These are most reactive, right? Then after that, they are less reactive. They are less reactive, and then they are even less least reactive, if there is a term called least reactive till here. And these are not reactive at all. These are silver, gold, platinum. They are not reactive at all. Okay. This is your reactivity series, a series which tells us the reactivity of each element in decreasing order. Okay. Now one more reaction is there for metals, which is between metals. A metal, according to the reactivity series, a metal, more reactive metal will displace a less reactive metal from its compound. That is a displacement reaction. What kind of reaction? Displacement reaction. Okay. So we know, as we know, zinc is more reactive than iron, so it will displace iron from its corresponding compound, which is iron sulfate, and thus we will get zinc sulfate and iron. Okay. Then we are talking about chemical properties of non-metals. Again, non-metals do react with oxygen, and we get non-metal oxide. These non-metal oxides are acidic in nature. Why? Because if you combine a non-metallic oxide with water, what you are getting? You are getting an acid. You're getting an acid. Non-metals do not react with water or acids. Again, water and acids both need electrons. Both need electrons. Now understand the nature of non-metals also. Non-metals also need electrons. They are electron acceptors. They want to accept electrons rather than donating them. They want to accept electrons rather than donating them, and that's why, my dear kids, that's why what? They do not react with water or acids. Because see, let's say I need 10 rupees. Okay, very bad example, but let's say I need 10 rupees, and here imagine there is another teacher standing here. Let's say let's say someone is standing here, one of you is standing here, okay, and I ask you for 10 rupees, okay, but you said, ma'am, I also need 20 rupees. Ma'am, I also need 20 rupees. So then, will any transaction happen between us? Will any transaction will happen between us? No, na, because I need money, you need more money than me. Okay, so that way, yes, that way the reaction won't happen, right? So what water and acid need? Electrons. Non-metals also need electrons. Non-metals also need electrons, and thus the reaction can't happen, my dear kids. Okay, so that's why they do not react with water or acids. Now you have non-metallic oxide, I told you, but what is the nature of non-metallic oxide? They are acidic in nature, but there are some non-metal oxides that are neutral in nature. And what are those? Carbon monoxide, nitrogen oxide, water. These all are neutral in nature. Okay, that means they do not react with acid or base. Okay, they are not acidic nor basic. They do not react with acid, do not react with base. Amphoteric reacts with both acids and bases. Neutral do not react with acids or bases. Okay, moving on. How do metals and non-metals react? How do metals and non-metals react? So metals and non-metals react in a similar way. If I have the money and you, my dear kid, need the money, I give you the money, the transaction happened, right? So that is how metals and non-metals react. Metal have money, I am the metal. Non-metal do not have money, they need the money. Okay, they need the electrons. In case of chemistry, we talk about electrons, not money. So, and you need the electrons. So I will give those electrons to you, and the kind of bond that is formed is called ionic bond. That kind of bond that is formed is called ionic bond. Clear? Bond that is formed by transfer of electrons. A bond that is formed by transfer of electrons. Clear? Okay, moving on. So again, what kind of forces exist between them? Electrostatic forces. There is a positive ion, there is a negative ion. Okay, there is a electrostatic force of attraction between them, and it is one of the strongest bond. Okay, has one extra electron, it will lose this electron, and this lost electron will be gained by chlorine. It will be gained by chlorine, and that's how you get Cl minus. Cl minus. This is a cation, positively charged ion, and this is an anion. Okay, and when cation and anion make a bond, this bond is called ionic bond, my dear kids. This bond is called ionic bond. Okay. What are the property of ionic compound? Ionic compounds have brittle solids. Okay, they are brittle solids. They have high melting boiling point. Why? Again, to answer your doubt, yes, ionic compounds have high melting boiling point than covalent compound. Why? Because the bond form is ionic bond. Ionic bond is formed by the transfer of electrons. Okay, there is a positive ion and there is a negative ion, and there is strong electrostatic attraction between them. If you want to break the bond, you need to put really high energy, and by high energy I mean high melting and boiling point. That means you need to put really high energy. That means the melting and boiling point is really high. Next is solubility. Okay, ionic compound are soluble in polar solvents. Where are they soluble in? Polar solvents. Why? Because ionic compound have poles. We just discussed it, what are poles and everything. Okay, so ionic compounds have poles, positive and negative poles, right? Similarly, your polar solvents also has poles. So like dissolves like, it dissolve polar compounds. Clear? Electrical conductivity in molten state, they do not conduct in solid state ionic compound do not conduct electricity, but in molten state solution they have the required ions, and that's why they conduct electricity. Minerals and ores. Minerals, what are minerals, what are ores? You know that, right? Minerals are natural inorganic substances that exist in our earth crust. Ores are those minerals from which any metal can be extracted conveniently. Then we do enrichment of ores. Enrichment of ores means that you remove all the impurities. Remove all the impurities. What is that impurity called? That impurity is called gangue. That impurity is called gangue. So if you remove all the impurities from the ore, you have only the metal, the mineral that has the metal. Okay, and then you use these techniques actually to filter out the impurities, to remove the gangue. Okay, and that is called enrichment of ore. That ore is used to, that your ore is used to get the pure metal, my dear kids. Now how we get it, that is in the next slide. Okay, these are the techniques. Hydraulic washing, froth flotation, magnetic separation, these all are all the techniques that we use to enrich any ore, to remove all the gangue particles. Clear? Okay. Activity series, again this is same as the reactivity series. This, according to this series, these are the metals of high reactivity: potassium, sodium, calcium, magnesium, aluminum, right? Metals of moderate reactivity are zinc, iron, lead. Metals of low reactivity: copper, mercury, silver. And metal of actually no reactivity, they are gold reactive at all. They do with any compound that is present there, they will exist in their native state. Clear? Any doubt you have, please write it in the live section. I will answer your doubt. Next, extraction of ore. So firstly you do, right, we remove all the impurities, sand, dust, particles, everything. After them, if metal, extract metals which are present as their sulfide or carbonate ores. So for sulfide ores you do roasting. What is roasting? We heat the metal ore. In excess of oxygen. Yes, we heat the metal ore in excess of oxygen. We heat the metal ore in excess of oxygen. Okay, and we get, after we heat it in excess of oxygen, we get zinc oxide, right? Now oxide of metal, we get the oxide of the metal. Now after we get the oxide, we do the reduction. A reduction means removal of oxygen, right? We do reduction using a reducing agent, right? So after reduction, this is removed and we get our pure metal. Then obviously you do purification and you get your pure metal. Okay, this table is important. Okay, just remember everything is written here. So also if you add here, the metals that I have shown you. Okay, that will be much more easier for you. Now calcination. What is calcination? Calcination means when you heat an ore, basically carbonate ores, when they are heated in limited supply or no, in absence of oxygen, when the carbonates ore are heated in absence of oxygen and gets converted into their respective oxides. Okay, this is heating in absence of oxygen. Heating in absence of oxygen. Now, metals of low reactivity, you do not need to worry much. They will exist as sulfide ore. And then you have metals of known reactivity. They will exist in their native state. So you just need the purification only. You need to just refine them and you will get your metal. Now, metals of low reactivity, they will exist as sulfide ore. Again, sulfide ore are, how do you get your metal from the sulfide ore? Yes, we get it by roasting. We get it by roasting, right? And after roasting, you get the same process, oxide, then reduction, and then that's how you got your metal, and then you refine your metal. Are you understanding, my dear kids? Is it clear to you all? Last chapter, my dear kids. I believe we can do it, right? We are almost there. This is one of the most scoring chapters. Okay, again, I told you in the metals and non-metals also, but this one is the chapter which will make yes, major question will come from this one and metals and non-metals. Those two are important chapters, so focus on these, make them a priority. Okay, now what is carbon? Carbon has an atomic number of 6. It has 6 protons, 6 electrons, 6 neutrons, right? There are plenty of compounds that it can form, you know. Carbon can form million of compounds, okay? Carbon can form million of compounds. Carbon can form millions of compounds. That's why we study it in a entire chapter. We have an entire chapter dedicated to it in chemistry. That is carbon and its compound. That is carbon and its compound. Okay. Okay, so why do we study it? What makes it so versatile, so, you know, unique that you have an entire chapter dedicated to it, my dear kids? Because of its property. What properties? Catenation and tetravalency. What is catenation? Catenation means it can form long chain of compounds. It can form compound with itself first of all. It can form bond with itself, okay? And then it can form long chain of bond with itself and other atoms. It can form long chain of bond with itself and other atoms. Okay, and due to that it exists as millions of compound of carbon exist. Next is tetravalency. Valency means ability of an atom to combine with other atoms. This is the ability of an atom to combine with other atoms. Carbon at one time can combine with 4, right? It has a valency of 4. What is the electronic configuration? 2, 4. It needs 4 electrons to complete its octet. So it can either form a cation or it can form an anion, right? Either it can lose these 4 electrons and form a cation, or it can do what? It can gain 4 electrons and form an anion. Both are not possible for it due to energy reasons, okay? If it tries to gain 4 electrons, then it will have 6 protons trying to balance 10 electrons. 6 protons trying to balance 10 electrons. That is not favorable, okay? That is energetically not favorable. Similarly, if it loses these 4 electrons, too much energy is required to remove these 4 electrons, okay? Too much energy will be required to remove these 4 electrons. That's why it is not possible, okay? Clear? Okay, that's why it cannot form cation or anion. So what it does, it forms covalent bonds. That is, it shares its electrons with other atoms. It shares its electrons with other atoms and form covalent bond. Covalent bonds are formed by sharing of electrons, okay? Now, there are 3 types of sharing that can happen. Either only 1 electron, either both the carbon can share 1 electron and form a single covalent bond, or they can share 2 electrons and form a double covalent bond. Clear? Or they can share 3 electrons and form a triple covalent bond. or they can share these 3 electrons and form a triple covalent bond. Okay, clear? Now, what are the properties of covalent compounds? They have low melting boiling point. Why? Because the bond is formed by sharing of electrons, not transfer. Only sharing is happening, right? You can imagine it in this way. You have 2 kids, Raju and Chota Bheem. Okay, so Raju has roti, let's say, and Chota Bheem has dal. So what they do? Actually, I should take example of Raju and Jaggu, right? So Raju and Jaggu, they were really good friends. So Raju have, let's say, rotis, 2 rotis. Not 2 exactly, he have some rotis, and Jaggu have dal. So they both want to fill their tummies, okay? They want to eat the dal roti. So what they do, Raju will share some of his chapatis with Jaggu, and Jaggu will share some of his dal with Raju, okay? That's what sharing is about, okay? You should also share with your friends, family, okay? Okay. So since this bond is formed by sharing, not complete transfer, okay? So if Raju did not consent it, so there will not be any transfer, okay? So what I'm trying to say is the bond is really weak in case of covalent bonds, equivalent compounds. The bond is really weak, and because of that reason they have really low melting and boiling point. Plus they are poor conductor of electricity. Why? Because there are no electrons involved. The bond is formed by sharing of electrons. They are insoluble in water because water is a polar solvent, and covalent compounds are, they are not polar. Okay, now one question will come to your mind that, ma'am, polar covalent compounds. Polar covalent compounds, they can be soluble in water. So no, my dear kids, your polar covalent compounds, yes, they have covalent bond, but they also have poles. They also have poles. Right? They have poles due to the electronegativity difference between the 2 compounds. Okay, the electronegativity difference between the 2 compounds, but the charges are very small, del positive, del negative, right? Very small charges are there. Okay, so not entirely they have plus 1, minus 1. Okay, this is very small charge. Okay, and thus it can be, they won't that also means they won't dissolve in water or any other polar solvent. Why? Because the charges are really small. Clear? Now, which are they soluble in? They are soluble in organic solvents. They are soluble in organic solvents. Why? Because organic solvents do not have any charges. They do not have any poles. Okay, they are non-polar. Okay, that's why covalent compounds are soluble in them, because they do not have electrons. Okay, now allotropes. What are allotropes? Allotropes are made up of same chemical element, having same chemical properties, but differ in the physical arrangement. Allotropes are those compounds that are made up of same chemical element, have same chemical properties but different physical properties. Okay, physical arrangement actually. Okay, so for example, this is an allotrope of carbon. 3 allotropes we have: diamond, graphite, fullerenes. Diamond is an allotrope of carbon that looks like this actually. Clear? Every carbon, each carbon is tetravalent. Okay, each carbon is tetravalent. Each carbon has 4 valency complete. Okay, and it is very hard and it does not conduct electricity. Why? Because it does not have either of those, ions or electrons. Nothing it have. It does not have free ions. It does not have any free electrons for the electricity conduction. But it is very hard because this is 3D. This exists in 3D. Graphite is also an allotrope of carbon. Graphite is also an allotrope of carbon. It is a 2D array, 2D hexagonal array of carbon compounds, not compound. It exists in a 2D hexagonal array of carbon elements. Okay, you have carbon atoms in there. They arrange themselves in 2D hexagonal array. Okay, now this array, they have this arrangement. I'll draw it here. This is the arrangement, 2D hexagonal array. Okay, each carbon is bonded to 3 other atoms. Each carbon is bonded to 3 other atoms. It has 1 free electron. It is trivalent. It has 1 free electron, and due to this 1 free electron, it conducts electricity. Due to this one free electron, it conducts electricity. Okay, it is very soft. Why? Because these layers, in between these layers, there is no strong attraction. Okay, this is just covalent bond. There is covalent bond in between here also, right? Then among these layers, in between these layers, the attraction is really weak. Why? Because the bond length, because the length is very much. One layer is here, one layer is here. The attraction will be very less. Okay, so even if you hit them with a little force, they will break. It will slide away. It will slide away. That's why graphite is very soft. Next is fullerenes. You can call them Buckminster fullerenes, C60. Clear? Holospheres. Okay, it is neither too soft nor too hard. That much. Like, that's all you need to know for fullerenes. Now, hydrocarbons, my dear kids. Hydrocarbons are compounds that contain only carbon and hydrogen. There are 4 types: alkanes, alkenes, alkynes, and cycloalkanes. What are alkanes? Alkanes are saturated. So you have 2 types of hydrocarbons: saturated and unsaturated. Saturated and what does saturated mean? Saturated means they do not have any double or triple bond. They only have single bonds. If only single bonds are there, that is called a saturated compound. Okay, for example, alkanes and cycloalkanes. Clear? Unsaturated compounds are those compounds that have at least one double or triple bond. They have either double bond or triple bond, and one of those should be there. Okay, that is unsaturated hydrocarbons. Okay, now alkanes, what is the general formula of alkanes? CnH2n plus 2, right? Cycloalkanes, the general formula is CnH2n. It is similar to those of alkenes, which is CnH2n, right? But there is a difference. In cycloalkanes, there is no unsaturation. This double bond or triple bond is called N-saturation. There is no unsaturation in cycloalkanes. Okay, so the general formula is CnH2n plus there is a ring. No unsaturation plus ring is also there. That is cycloalkanes. For example, you have cyclohexane, cyclopentane. Clear? Okay. Alkenes are unsaturated hydrocarbons. Alkynes are also unsaturated hydrocarbons. The general formula is CnH2n and it has CnH2n minus 2. Remember the general formula so that you can attempt the question. The MCQ will come from the general formula. Okay. Homologous series. What is homologous series? Homologous series is a series of organic compound that have same functional group. Homologous series is a series of organic compound that have same functional group. Yes, same general formula, same functional group, and each successive member differ by CH2 unit. They have same general formula, same functional group, and each successive member differ by a CH2 unit. They have same functional group, same general formula. That means they will show similar chemical properties, right? Because each functional group give same chemical reactions. So if they have same functional group, they will show same chemical properties. Clear? Now these are the compound. These are the homologous series. Few series are there. We have alkenes is one, alkene is one, alkyne is also one. Clear? Clear? Okay, now how do you write the name of these? These all are homologous series. That means, remember, they have same functional group, same general formula. They have same chemical properties but show gradual change in physical properties, right? And each successive member differ by CH2 unit. Only these 5 points you need. Same functional group, same general formula, same chemical properties, show gradual change in physical properties, and each successive member differ by a CH2 unit. Okay? Repeat with me. Okay. So, chlorine, bromine, these are all the functional group that you have actually. So when you are writing the name, nomenclature if you are doing, How do you write the name? If you have Cl, chlorine, bromine, iodine, fluorine, any halogen there, so you write the name as haloalkane. You write the name as haloalkane. Clear? Then you have alcohol. How do you write the name? Any compound you have, add all at the end. Aldehyde, if you have any compound, any alkane, you add Al at the end. For ketone, add ONE at the end, and on at the end, and okay, halo you add. This is used as a prefix. Prefix mean added at the front of the name. Then you have alcohol, all, aldehyde, al, ketone, on, carboxylic acid as oic acid. Carboxylic acid as oic acid, my dear kids. Clear? Now let's try to name some. Let's write the IUPAC nomenclature. So in chemistry, we'll talk about two type of nomenclature: IUPAC nomenclature and common names. Okay, common names or general names, trivial names you can call it. Okay, so common names are normally given to them from the way they are synthesized or the purpose that they are used for. But IUPAC name is scientific name. Okay, that is given after following a set of rules. So how do you name any compound that is given to you? You add prefix, then you root and a suffix. Okay, confused? Do not get confused. Okay. We'll start with the parent chain. Now what is the parent chain? It is the chain containing the maximum number of longest carbon chain. It is the longest carbon chain. Containing the functional group. It is the longest carbon chain containing the functional group. Okay. So firstly you should determine which functional group is there, right? Which functional group is there, and functional group are normally added as a suffix, that is at the end of the name. Okay, some are added as prefix, for example halogens, right? Now what you do, you have a root. Which is a root? The longest chain, longest carbon chain. How many carbons were there in that chain? That is your root. That is your root. And if you have any substituent means any extended part. So let's say if I have like this, if I have this CH3, if it is visible to you all, at this is CH3. Let me rewrite it. This is CH3. Clear? So if this CH3 is there, it will act as a substituent. It will act as a substituent. This CH3 will act as a substituent. Okay, so you write the name of substituent as prefix. Then you figure out the root. How many carbons are there? 1, 2, 3, 4 carbons are there. That is the longest carbon chain. That is your root. And 4 carbons. What is the root? Bute, right? Bute. Substituent, we have this methyl group. This is methyl group. At what position is your substituent? If we start calculating from here, 1, 2, 3, 4. So at 2. At 2 you have methyl group. Okay, and 4 means bute, and then the suffix, since it is in, there is no, what functional group is there? Alkene. Functional group is alkane, and you add ane at the end. So 2-methyl butane. Sorry if I butchered it. So properly you write it as 2-methyl butane. Similarly, these are the root name. If one carbon is there, meth, 2 eth, 3 prop, 4 bute, 5 pent, 6 hex, 7 hept, 8 oct, 9 non, 10 dec. Clear? Up till here you need it. No one gonna ask about beyond that. Okay. That's how you write any function, any name of any organic compound that is given to you. For now, you need only basic one. Okay, if you are pursuing chemistry in your next year 11th standard, then you will need some tougher ones. Okay, then you will need to write some really tough ones. Okay, so do not worry. we'll solve them also. Chemical properties of carbon compounds. What chemical reactions are shown by carbon compounds? So there are majorly 4 type of reactions shown by carbon compounds: combustion, oxidation, addition, substitution. Combustion means if you provide oxygen and you get heat and light. Combustion means if you provide oxygen and you get heat and light. Heat and light, right? That is combustion reaction, right? Plus carbon dioxide also. When combustion is happening, carbon dioxide is also getting produced. Next is oxidation. Oxidation means addition of oxygen. There is a difference between combustion and oxidation. Combustion may you add oxygen. There is no limited supply of oxygen. You have an unlimited supply of oxygen. But if you add oxygen in a limited manner, in a limited supply, that is oxidation. Okay, that is oxidation. For example, this is very important. Ethanol. Oxidation of ethanol will give ethanoic acid. Again, oxidation means addition of oxygen, okay, in a controlled way, okay. That's why there is no heat and light. But in combustion, you are combusting it. You are providing unlimited oxygen. That's why you're getting heat and light also. Next is addition reaction. Addition reaction is shown by unsaturated compounds. It is shown by unsaturated compounds. What are your unsaturated compounds? That have double and triple bond. Compounds that have double and triple bond, right? That is unsaturated compound, okay. So in there they add hydrogen. That is, this is hydrogenation reaction. This is hydrogenation reaction. Important reaction is there, okay. We use it to convert unsaturated oils into saturated fat. Unsaturated oils into saturated fat. Clear? The last reaction is substitution, my dear kids. Substitution reaction. So substitution reaction is given by saturated compound. Compounds having only single bond. Saturated compounds. Okay. So what is happening here? One atom comes, you have atom, chlorine here, it comes and replaces one of the hydrogens, substitute one of the hydrogens, and that's how you get CH3Cl. CH3Cl, it replaced one hydrogen. Clear? That is substitution reaction, okay. Ethanol and ethanoic acid. What is ethanol? Alcohol, right? It is a major component of alcoholic drinks. People drink it, right? It is colorless liquid, it is soluble in water, and it is a very good solvent. Also, it is used as an as a disinfectant also. Okay, antiseptic. As a disinfectant you also use it. Then you have ethanoic acid, CH3COH. Okay, some students are getting do get confused. How do you write it, ma'am? So you can either write it as C2H5OH, or you can write it as CH3CH2OH, or you can write it as CH3CH2OH, right? What is ethanoic acid? It is 5 to 8% acetic acid. No, sorry. Ethanoic acid is CH3COH. How do you synthesize vinegar from acetic acid? So you take 5 to 8% acetic acid and dilute it. Okay, a solution which has 5 to 8% acetic acid is vinegar. It is vinegar. Clear? Now, chemical properties of ethanol. This is important. Ethanol show combustion. So basically it combines with oxygen, and what do we get, my dear kids? We get carbon dioxide and water. Carbon dioxide and water. Now some of you might be thinking, ki, how do I get CH3CH2OH or C2H5OH? This is here CH3CH2OH. Clear? And if I can just count it, C2, 1, 2 carbons, C2. How many hydrogens I have? 1, 2, 3, 4, 5, H5. And we have an OH group to distinguish if it is an alcohol or aldehyde. This is ethanol. So when you combust ethanol, we get carbon dioxide plus water plus heat and light. Whenever combustion is there, heat and light will be produced. Oxidation. Oxidation is a different case. Heat and light may be produced or may not be produced. Next is reaction with sodium. When ethanol reacts with sodium, what do we get? Sodium ethoxide. Sodium ethoxide plus hydrogen gas is evolved. This is sometimes used as a test for ethanol. test for ethanol. So if ethanol is there and you add sodium metal to it, there will be evolution of hydrogen gas. This gas evolves with a pop sound. This gas evolves with a pop sound. Next is dehydration. Dehydration means removal of water molecule. So if we take ethanol and we remove one water molecule from it, that is dehydration reaction. And the reaction happens in presence of hot concentrated sulfuric acid. Or you can say when you heat ethanol at around 443 Kelvin in presence of hot concentrated sulfuric acid, at around 443 Kelvin in presence of concentrated sulfuric acid, we get alkene. We get ethene actually. We get ethene. Plus water molecule is released. Okay. Dehydration, that is removal of water molecule. So when in your case-based question, sometimes they will ask. So if you have ethanol and you burn it and you heat it up to 443 Kelvin in presence of concentrated sulfuric acid, what will happen? They say formation of ethene will happen. Formation of ethene will happen. Chemical properties of ethanoic acid. This is ethanoic acid, CH3COOH. That's how you write it. You write it as CH3 COOH, right? So first reaction it shows is esterification, that is formation of ester. That is formation of ester. So what is esterification? When ethanol and ethanoic acid combine in acidic medium, when ethanol and ethanoic acid reacts in presence of an acidic medium, in presence of an acid, okay, we get an ester. We get an ester. So when ethanol and ethanoic acid combines, we get ethyl ethanoate. Ethyl ethanoate. Okay. This part C2H5 comes from the alcohol. This part OC2H5 comes from the alcohol, and this part CH3CO. This comes from the acid. This comes from the acid, and we have one water molecule also, minus H2. Clear? That is esterification, formation of ester. These are sweet smelling substances. Okay, they smell really nice. They are used basically in perfumes. Okay, if you go somewhere it's smelling really nice, it is due to ester. Next reaction is saponification, my dear kids. What is saponification? It is the reverse of esterification. So in esterification, we combine ethanol with ethanoic acid in presence of an acidic medium. If we reverse that reaction, ester react with a base, and we get acid plus alcohol. Acid plus alcohol. This is a salt, sodium ethanoate. This is a salt, sodium ethanoate. Basically, it is soap. It is soap. What is soap? Soap is sodium or potassium salt of fatty acids. Sodium of potassium salt of fatty acid, or you can say sodium and potassium salt of acids. So this is acid, and this is a sodium salt of acid. Clear? So this is soap formation. That's why it's called saponification. Clear? And we get our ethanol back. Now, how do you test ethanoic acid? How do you test ethanoic acid, my dear kids? The two tests are there: sodium hydrogen carbonate test, sodium bicarbonate or sodium hydrogen carbonate test. So when you treat ethanoic acid with sodium hydrogen carbonate, there is evolution of carbon dioxide gas. There is evolution of carbon dioxide gas with brisk effervescence. Again, to answer your doubt, yes, effervescence means bubbling of any gas. It need not to be hydrogen, it need not to be carbon dioxide. Any gas bubbles in a solution, it is called effervescence. Bubbling of a gas in a solution is called effervescence. And when sodium hydrogen carbonate reacts with ethanoic acid, what we get? We get sodium ethanoate. Yes, we get sodium ethanoate and carbon dioxide's brisk effervescence. Next is ester test. When ethanol combines with ethanoic acid, we get this fruity smell of ester. So that also is used as a test for ethanoic acid if you want to test whether ethanoic acid is present or not. One more thing is there: if you want to differentiate between ethanoic acid and ethanol, then also you use this test, because ethanol does not react with, if you have ethanol, which is C2H5OH, and if you treat it with sodium hydrogen carbonate, there will be no reaction. So NaSCO3 sodium hydrogen carbonate, sodium bicarbonate test is also used as a test to distinguish between ethanol and ethanoic acid. Clear? And one more is there, litmus test, right? So what does ethanoic acid will do with the litmus test? And what about ethanol? Last one, okay, this one I'll explain you why I left it blank. One test is there for unsaturation. If you have unsaturation in a compound, how do you test it or how do you detect it? So the test is, yes, bromine water test. It is bromine water test. Clear? Bromine water test. So if you have a saturated compound, let's say this is saturated compound, and the other side you have an unsaturated compound, and if you add bromine water to each of these, if you add bromine water, Br2 water, bromine water to saturated compound and bromine water to unsaturated compound, what will be the product? So if you have bromine water, if you add bromine water to a saturated compound, firstly bromine water is reddish brown in color. It is reddish brown in color. Bromine water is reddish brown in color. So if you put bromine water in saturated compound, it will retain its color. It will retain its color. And in case of unsaturated compound, the bromine water gets decolorized. Okay, it loses the reddish brown color in case of unsaturated compound. In case of saturated compound, it will retain its color. In case of unsaturated compound, it will get decolorized. Clear? So that is a test for unsaturation. We have left soap and detergent. So what are soaps and what are detergents? Let me quickly discuss it with you. So we have, yes, so soaps are, what are soaps? They are sodium or potassium salt of fatty acids. They are sodium or potassium salt of fatty acids. Okay. Then we have detergents. What are detergents? They are ammonium or sulfonated salt of fatty acids. Ammonium or sulfonated salt of fatty acids. Okay. Soap work in soft water only. Detergents will work in soft as well as hard water. Hard water has magnesium, calcium ions, and due to the presence of these ions, soap will form scum. Scum is this impurity, not impurity exactly. It's a compound that is formed when hard water reacts with soap. Okay. What is micelle? Micelle is soap molecules. It is a formation. This formation is micelle. If you have oil or dirt in the center, the soap molecule align themselves around the oil or dirt in such a way that the hydrophilic end is lying outward and the hydrophobic end is attached to this oil or grease particle. Okay, there's a scum formation. That's why we do not use soap in hard water. Okay, now soaps are biodegradable, detergents are non-biodegradable. That is the major difference. Clear? So that was all for you. Okay, my dear kids, I hope you enjoyed this session. If you did, please give it a thumbs up and do subscribe to Deeksha Vedantu Class 10 channel for more such amazing content. I hope you enjoyed it. I hope you complete your chemistry in 3 hours with me. Okay, all the best for your board exams. Take care. Bye bye.